There's nothing better than enjoying a beautiful sunny day while on a hike. I'm staying hydrated and even brought along with me a little snack. If you're like me, you might pick out all of the chocolate candy and eat those first. A way of unmixing the mix. But can you always unmix a mixture? Could I separate my drink back into water and the powder I mixed in? Let's find out together in this episode all about mixtures and solutions. Mixtures are all around us. We breathe a mixture of gases in the air. We eat a mixture of foods for pretty much every meal, and we are even entertained by mixtures. A mixture is simply a combination of two different substances that don't lose their identifying characteristics when combined. For example, this salad is a mixture, but the lettuce is still lettuce, the chicken is still chicken, and the blueberries are still blueberries. You get the idea. That's a good blueberry. Mixtures can be made with all solids, like our trail mix, or all liquids, like these bubbles, or all gases, like the air we breathe. Mixtures can also be made by combining a solid and a liquid, like our sports drink. The most important thing to remember is that the components of a mixture are not changed when mixed with other materials. Sometimes the two or more ingredients in a mixture all look the same, but sometimes they do not. We can divide mixtures into two main categories: homogeneous mixtures and heterogeneous mixtures. In a heterogeneous mixture, the substances are not evenly distributed. The uneven distribution is what makes this lava lamp so fun to watch. Oh, crazy. My trail mix is a heterogeneous mixture. That's what makes it so easy to find those chocolate candies and unmix them or separate them from the rest of the mixture and eat those first. The candy, peanuts, and raisins, why do we add these? All keep their identities. In a homogeneous mixture, all of the substances are distributed evenly throughout the mixture. This means that you wouldn't be able to unmix or separate the different components easily. Ocean water is a good example. We know ocean water is salt water, but you can't just scoop out all of the salt. Our blood is also a mixture of red and white blood cells, platelets, plasma, and a bunch of other things our bodies need. But those components aren't easily separated. What does my sports drink look like after I added the powder to my water bottle? Is it all the same color? Are there chunks of drink powder, or is it all the same consistency? This sports drink is a homogeneous mixture, or uniform throughout. When a homogeneous mixture cannot be easily separated because one substance dissolves in the other, the mixture is a solution. Solubility is a physical property of matter, which is the ability of matter to dissolve into other substances. This means that all solutions are mixtures, but not all mixtures are solutions. If you're still here liking this video, let us know, and hit that subscribe button so you never miss an episode. A solution is made up of a solute and a solvent. A solute is something that dissolves in a liquid, and a solvent is the liquid that something dissolves in. So when you want a cozy drink and you ask for some hot cocoa, the warm milk is the solvent, the liquid that is doing the dissolving, and the hot cocoa mix is the solute that is being dissolved. I think we need to look at a few more examples. Here I have several glasses of water. Together, let's add a separate substance to the water to then determine if we have a solution, a homogeneous mixture that isn't easily separated, or a heterogeneous mixture that allows all of the components to keep their separate identities. First, we have some vegetable oil. I'll add this to our water. No matter how much I stir and stir, the oil just will not dissolve in the water. So this is a heterogeneous mixture. Next up is some salt. The salt fully dissolved in the water. So this is a homogeneous mixture or a solution. Next up is some cinnamon. Most of the cinnamon is just hanging out here on the top of the water. Some of it settled to the bottom, but it definitely did not dissolve. This is a heterogeneous mixture. Last we have some sand. As you can see, the sand just settled at the bottom. It did not dissolve in the water. So this is a heterogeneous mixture. What about the unmixing? Can you separate mixtures and solutions back to their original components? Many mixtures can be separated by simple physical means, like picking out all of the different components of my trail mix, so I can be generous and give away all of the raisins. If substances in a mixture are different sizes, like this sand and gravel, we can use a sifter to separate them. The sand will fall through the holes because it's smaller, and the larger pieces of gravel are left behind, separating the two. Filtration can be used to separate solids and liquids, like when you make mac and cheese, and you strain all of the water from the noodles before adding the delicious cheese. The liquid water moves through the filter, but the solid noodles do not. You can also use physical properties, like magnetism, to separate mixtures. This might be the most fun option. I have a bag of sand and iron filings that need to be separated, and this magnet will do the trick. The magnet attracts all of the metal filings and leaves the sand behind. So far, we've separated mixtures, but not solutions. Solutions are usually much more difficult to separate than other mixtures. Difficult, but not impossible. Changing the phase of matter that the solution is in is a great way to separate the components. Here, we are boiling the solution of salt and water we made earlier. Let's watch how the water leaves by turning into a gas called water vapor. After a while, the salt should be all that's left behind. Another way to separate a solution is by using solar power with a solar still. I have poured my sports drink from earlier into this larger bowl. In the middle, I will place an empty glass. I don't want to just separate the two components. I want to be able to see the clear water again. So I'm going to trap the water vapor with this plastic wrap. Then I will weigh that down, causing the condensing water to roll and fall into the empty cup, hopefully. It worked. This cup is filled with clear water and the bowl just has thick sports drink syrup. Let's let this completely dry out. Now we have water and sports drink powder again. Kind of. So the next time you need to unmix a mixture, remember, it might be difficult, but not impossible. And if you want to learn more science, you can check out this video next. Oh, there it goes. There it goes. Is it gonna glob it? I think I'm just gonna watch this for the rest of the day.